Here are a few more examples of the derivative of a trig function using the chain rule. All right, so for example number 9, we have the tangent of a quantity. So we're going to need to use chain rule. I'm going to take that quantity and bring it out here to the side for just a second and say u is equal to cosine x. All right, so to begin with, when we do the derivative of tangent anything, it's going to be secant squared of that thing. So there's the derivative of the outside. All right, now let's find the derivative of the inside. The derivative of cosine is negative sine. And so we can say for chain rule, derivative of the outside, derivative of tangent anything is secant squared that thing, times the derivative of the inside, the derivative of cosine was negative sine. We could pull our negative out in front, but other than that, not really anything that we can do to clean that up. You can multiply in any order, so you might want to put the negative sign out in front just to avoid any misunderstanding that, it's just secant squared of cosine, not also of negative sine. So you could write it either way. All right, look at the next one. So for the next one, we've got y is equal to secant 2x squared minus tangent 2x squared. I'm going to rewrite those first just so it's a little more obvious how to use our power rule with this. So let's start with the first one. If you have anything to the second power, we're going to take the derivative of the outside by saying 2 that thing to the first power. All right, so anything to the second power is going to be 2 that thing to the first power. Now we need to multiply by the derivative of that thing. We need to multiply by the derivative of the inside. So I'm going to come over here and I'm going to treat this as an entirely separate problem. All right, because I'm going to need to use chain rule with this as well. So this is going to be chain rule inside of chain rule. So for instance, if I let u be equal to 2x, then the derivative of secant anything is going to be secant that thing tangent that thing. And then I need to multiply by the derivative of that thing, the derivative of the inside. So the derivative of 2x was 2. So look at that one more time. The derivative of secant anything would be secant that thing tangent that thing. And then times the derivative of that thing, the derivative of 2x is 2. All right, so this was the derivative of the outside. And we're going to take this separate problem we just worked and bring it in. That will be the derivative of the inside. All right, then let's do that same thing with tangent 2x. I'm going to go ahead and pull that out to the side, so we could call that v if we want to. So if this was something to the second power, the derivative would be 2 that thing to the first power. And then I need to multiply by the derivative of that thing. So let's come over here and let's think about the derivative of tangent 2x. The derivative of tangent anything is going to be secant squared of that thing. So the derivative of tangent anything is secant squared of that thing. Then I need to multiply by the derivative of that thing. So the derivative of 2x would be 2. All right, so this was the derivative of the outside, and this is the derivative of the inside. All right, so just doing a little bit of cleaning up, we could go through and say 2 times 2 is 4, and then secant 2x times secant 2x would be secant squared 2x times the tangent 2x. All right, then over here, 2 times 2 is 4. And we had a secant squared and we had a tangent to the first. So secant squared and tangent to the first. Now, if you'll notice, those are identical. 4 secant squared 2x tangent 2x minus 4 secant squared 2x tangent 2x. So I literally am going to end up with 0. All right, look at another one. So for the next one, we've got the tangent of x cubed, that whole thing squared. So another way of writing that would be tangent x cubed, that whole thing squared. So you can see I've got a quantity being raised to the second power. So if I take the derivative of anything to the second power, it's going to be 2 that thing to the first power. So 2 that thing to the first power. Now I need to multiply by the derivative of that thing. So let's come over here and let's find out what the derivative of tangent x cubed would be. We're going to treat that as if it was its own problem. All right. So if you have the derivative of tangent anything, the derivative of tangent anything is secant squared that thing, right? So secant squared that thing. So that would be, if we're using this as an entirely separate problem, the derivative of the outside would be the derivative of tangent is secant squared, and then the derivative of the inside would be taking the derivative of x cubed. So the derivative of x cubed is 3x squared. So I'm going to move that 3x squared out in front, and so now I can pull that in. So derivative of the outside times derivative of the inside. All right, so to clean that up a little bit, 2 times 3 is going to give us 6x squared. And then we've got our tangent x cubed, and we've got our secant squared x cubed.